Assalamu alaikum everyone, how are you? Mole. We know that atomic mass, molecular mass, formula mass, when expressed in gram is called a mole. Right? Suppose, what is the molecular mass of water? H2O, 18. So if we take 18 gram of water, this will be called 1 mole. If we double it, 36 gram of water, we call it 2 moles, and so on. You know it very well. Same is true for elemental case. What is the atomic mass of carbon? 12, 1 mole. 24 gram, 2 moles. 36 grams, 3 moles, and so on. But if there are so many moles, like if I ask how many moles are there in 5,636 grams of sodium, it will become difficult. So we have a formula over here that you can see on the screen. This is your formula number 1 of your book. Number of moles is equal to given mass upon molar mass. Molar mass means atomic mass or formula mass. Okay, you know that where can we use atomic mass? We can we can use molecular or formula masses. And then another topic that we have done, that number of moles is symbolized by small n. Means you can write this formula in another way, like small n is equal to given mass upon molar mass. Is it clear? Actual formula is number of moles is equal to given mass upon molar mass, and if you use the symbol for number of moles, then small n can be used for number of moles, then the formula can be written as n is equal to given mass upon molar mass. This is your brief revision. Okay? And then another topic. What that topic is? The topic is Avogadro number. That if you take 1 mole of any substance, like we did yesterday, I brought here 1 mole of water, means 18 gram of water. We had here what 58.5 gram of salt, means 1 mole of salt in a beaker yesterday. We had 342 gram of sugar, means 1 mole of sugar. So 1 mole of sugar means 342 gram. I'm talking to those who were present yesterday. Okay? So suppose if you have 1 mole of water and then you start counting that how many water molecules are present in it, then it will be a constant value. Either I count, you count, or anyone else count. What is that value? Avogadro value. 6.02 into 10 to the power 23. 6.02 into 10 to the power 23. So 1 mole of any substance, like 1 mole of carbon means 12 gram. If you take 12 gram of carbon, then it will contain 6.02 into 10 to the power 23 atoms. If it's an element, it contains atoms. If it's a molecule, it contains, if it's a compound, molecular compound, we say molecules. Like 18 gram of water, 1 mole contains 6.02 into 10 to the power 23 molecules of water. Clear? And if you use ionic substance, then it will contain ions or ions accordingly. Now, how many particles in 1 mole of any substance? 6.02. In 2 moles of any substance, 2 multiplied by 6.02 into 10 to the power 23. In 5 moles, okay? So you can see on the screen, if we have 1 mole of carbon dioxide, it contains 6.02 into 10 to the power 23 molecules. If we have 2 moles, then we will multiply this number by 2. If we have 5 moles of sulfuric acid, then how many molecules it contains? We multiply 6.02 into 10 to the power 23 by 5, and by 15 in the next example, and by 15 in the next example. There is a difference in sodium and sodium plus. Sodium plus is a cation. Cation means having positive charge. So what is the general formula? That if we want to know the number of particles then Avogadro number should be multiplied by the number of moles. What is the value of Avogadro number? You know. And how many moles you have? Just multiply the two, we'll get the number of particles in it. Anyway, so what have we revised up till now? Formula number 1, you can see on the screen. N is equal to given mass upon molecular mass. And another formula is number of particles is equal to N into Na. I hope you are understanding it. Now, if we substitute the value of small n from equation number 1, from formula number 1 in the next one, then it will be changed like this. Then it will be changed like this. Okay? See, this is the formula. What is the value of n? You can see we are substituting the value of n given mass upon molar mass and writing it in place of it. So it will be like this. So this will be our final formula that we have used in the last numerical yesterday. What is the formula here? Number of particles equal to given mass upon molar mass times Na. As I told you yesterday that on Friday, means today, I'll be just we'll be practicing, revising whatever we have done, because it's not a simple topic. It needs a lot of effort from my side, from your side. Practice, practice, and practice. Only then. That's why I'm explaining it to you again. So the formula becomes number of particles equal to given mass upon molar mass into Avogadro number. And what do you mean by number of particles? Particles means could be atoms, could be molecules, could be ions or ions, whatever you say. Okay. Number of particles is a general term. If you have an elemental substance like aluminum, like carbon, like gold, like silver, then all of these contain what? Atoms. Suppose I have this 50 gram of carbon, then it must be containing what? Atoms. And if I want to find how many atoms it has, then I can use this formula that you can see on the screen, and I can rewrite it like this. Number of atoms is equal to given mass upon molar mass into Na. Or you can write given mass upon atomic mass. Okay? I told you molar mass can cover all kind of masses. Atomic masses, molecular masses, formula masses, so you can simply write molar mass. If you have some water in a glass, as we did a problem yesterday, and you want to find out how many molecules it has. Suppose the glass contains 100 gram of water, and you want to find out how many molecules it has. Then water is a compound. It contains molecules. So it's the same formula, number of particles can be written as number of molecules. That is the mistake there. Number of molecules, it's not molecular, it's molecule. Number of molecules is equal to given mass upon molar mass. Or number of molecules is equal to given mass upon molecular mass. Okay? Question. It will be our problem number 4. Calculate the number of atoms in, let's see, an element. Last time we had an example of a compound, but today we start with an element. Like you can take sodium in 46 grams of sodium. What is the symbol of sodium? Na. Right. So what is that data? What is given to you? What is given to you? Data. What is given to you? Mass of sodium. Given mass of sodium 46 grams. And I told you, whenever it is asked to find the number of atoms, number of molecules, number of ions, Avogadro number, the value of Avogadro number is understood. It is given to you. Okay? So that's why I write here Avogadro's number represented by, what is the value? 6.02 into 10 to the power 23. And since it's an atom, so at the end of the question paper, either in the board exam or in assessment or in test, its atomic mass will be given to you. So that's why I'm writing here also atomic mass of sodium, gram atomic mass of sodium is 23 gram. And what is asked? Number of atoms. Number of sodium atom you may write. See the data by yourself. What is given to you? Given mass of sodium 46 gram. When the question is about to find number of atoms, molecules, Avogadro number is already given to you. Understood? Atom, that is why its mass is given 23 gram. And what is the question here? So, what is the formula over here? Formula. Number of atoms is equal to given mass upon atom, atomic mass, times Avogadro number. What is the value of the given mass? 46 gram. What is the atomic mass? Multiply by Avogadro number. Now, either you first divide and then multiply the answer, or you first multiply and divide the answer, one and the same thing. Yesterday we first multiplied, then divided afterwards. Today we are dividing first. So 46, and when you divide 46 by 23, it will give you what? 22. And using your calculator, if you multiply these two, you will get 1.204 into 10 raised to power 24. This will be the number of atoms And then you will write in the result. What is the result? 46 gram of sodium contains 1.2 into 10 to the power 24 atoms. So nothing is new. This was just a practice. All right? See another question. All right, clear? Done? See the next question. Let me erase. See the question and then check what is asked. It's your self-assessment. Calculate the number of moles in 150 grams of calcium carbonate. Okay? Oh, yes, you are right. It's a question of the previous concept. We will do this problem and then another problem. So what is given to you over here? We have 150 gram of calcium carbonate. As I told you yesterday, that you can make your own questions and can show it to me. I'll check it for you. Like, calculate the number of moles in 450 grams of glucose. Like, calculate the number of moles in 1000 grams of carbon dioxide. Calculate the number of moles in 250 grams of carbon. So you can make your own problems. When you do this, you will become master of this topic. Okay? So what is the data over here? Since the question is easy, already you know, that is why I will be a little bit faster this time. Given mass, 150 grams. What else? Nothing else is given. Number of moles is to be found out. Formula and solution. I'm writing the formula solution directly. Okay, what is the formula to find out the number of moles? Given mass upon atomic or molecular mass. Calcium carbonate is an element or a compound? Correct, it's a compound. Compound means you should find its formula mass first, its molar mass first. Okay? So I write here, first find the molar mass of CaCO3. Calcium is atomic mass will be given to you. What? 40. How many calcium? Just one. No need to mention it. You have grown up in this. Now carbon 12, oxygen 16. Not explaining because you know it. 16. How many oxygen do we have? 3. 40, 12, 48, 100. Okay. Now we will apply the formula. Number of moles is equal to, you can write a small n over here, given mass upon molar mass. What is the given mass here? 150. How many? What is the molar mass? 100. So the answer is 1.5 moles. Number of moles. Remember that we are doing with respect to our demands, means since we have to show these steps in board's pattern, that is why. Otherwise, one can answer it in a single step, that 150 divided by the molar mass of calcium carbonate, 150 divided by 100, we get the 1.5. And don't forget to write the result. It carries a mark, 1 mark. Okay? Now, what will we do in the last 3 or 4 minutes? The question will become answer and answer will become question. What does it mean? I'll write there now, what is the mass of 1.5 moles of calcium carbonate? Means I am reversing this question. Page number 22, problem number 2. What is the mass of 1.5 moles of calcium carbonate? So this time mole is given and mass is to be found out. Mass is given, moles we found. So the case is reversed. It means the same formula would be used, but the subject will be different. Subject means, for example, look at the board quickly. You know it because you have done so many times in maths. What is the subject right now? What is the subject means? This is for A. Now, if you want to find C, then C and A will interchange their position. Then the formula will become B upon A into D. Okay? Or make it simple. You can just see. What is the subject here? A. It means you can find the value of A. But if you want to find the value of C, then you can interchange these places and C will become the subject. The same logic we'll do over here. data, mass, sorry, moles, number of moles, 1.5. What is asked? Mass of CO3 is asked. Solution. Again, we have see the two things, mass and mole. So we'll use the same formula, number of moles equal to mass upon molar mass. So as usual, first we'll find out the molar mass. First, we'll find out the molar mass of CaCO3. The same I'll do over here, but quickly. 40 plus 12 plus 16 into 2, and it will become 100 gram. Okay? Now the formula. Number of moles. I will ask a question. What is the nonsensical mistake I did here? What should not I write? Yes. This is illogical to write given mass. No. Mass is to be found out. So that's why we will only write here what? Mass. Because the mass is not given. We'll find it out. Okay? Now since we have to find mass, the formula will be changed. This will be written with number of moles. You did it so many times in mass. I hope that you have no problem. Okay? Look at the board here quickly. A is equal to B upon C. Now if I want to find B, or if I want to make B as a subject, I should write C over here, so it can be written as A into C is equal to B. And finally the formula will become B is equal to A into C. The same logic we'll use over here. Or the final formula is mass is equal to number of moles, interchanging the sides. Why? Because it is generally a way that whatever you want to find should be written on left hand side. So since our task is to find mass of carbon, that's why I just interchange their positions. Now substitute the values. Number of moles. How many moles? 1.5. What is the molecular mass? 100. The answer will become 50 grams. I hope that now you have understood clearly problem number 2, page number problem number 2, page number 22. Do it by yourself. Result you will write 1.5 moles of calcium carbonate is 150 grams. So during the weekend, practice the work. Prepare yourself for chapter number 1. Next, on Monday, you will be having your test. That's all for today. Thank you so much. Have a nice weekend.